Eccoci qua, buongiorno a tutti. Ci scusiamo.
Good morning, everybody. Sorry for being late. We had a few technical problems, but now we can start. So, welcome to the Intermediate Scientific Conference of the ITACA project. My name is Silvia Angelini. I am a researcher at the CNRIRBIM, which is the partner of this project and the organizer of this event. The ITACA project has the aim of favoring a more sustainable use of fishery of stocks and small pelagics in the Adriatic, but also promoting the profitability of enterprises. Now, we will speak about the ITACA project during the first speeches of this morning's session. Now, I would like to give you some technical information. Now, the event is available in three languages: English, Italian, and Croatian. Now, at the bottom of your screen, you will find a button which will enable you to choose the channel you prefer. I would like to remind all speakers to speak slowly so that the interpreters can do their job. And during the presentations, if you have any questions, those questions will be written in the chat and asked at the end of the event. Now, I would like to give the floor to the director of IRBIM, Gianmarco Luna, who is here with us today, who will welcome you all and will introduce today as well. Gianmarco, you have the floor. Good morning, Silvia. Good morning, everybody. I am very glad to be here today and to be able to welcome you to this medium-term conference of the ITACA project. Now, I'm here in the capacity of the director of the IRBIM, which belongs to this Italian Sea National Research Center, known as CNR. Now, the CNR is the largest public research body in Italy. It is the only that responds to the Italian Ministry for Research, and it is composed of a network of 80 research institutes, such as the IRBIM Center, which deals with a lot of scientific disciplines: biology, marine biology, chemistry, food science, engineering, social sciences, and biomedical sciences. Now, the IRBIM CNR Institute is present in 3 regions, and it deals specifically with the study of life in the sea and the ocean. So, what we do is promote research activities, both basic research and applied research, in order to get to know something more about life in the ocean. So we want to expand our knowledge on sea organisms and their evolution, their changes based on climate change. We also focus on blue technology as well as on fishery technology. Now, the planet is facing very important challenges and will have to face even harder and even more difficult challenges in the next 10 years. And these challenges also have to do with the very survival of our species. By 2050, as we all know, we will have to face a very important challenge, namely that of being able to find food for a population of more than 9 billion people. And this challenge is contained within the UN 2030 agenda. And this agenda includes fishery activities. I believe that fishery activities, fishery in general, will play a very important role in providing substance to the human race, which is why projects such as this are very important. But I do not want to drag too long, so I would like to give the floor to all the other speakers, and I enjoy the proceedings. Every success. Thank you very much, Gianmarco. Thank you, Director, for introducing the very interesting event and for highlighting the importance of fishery activities and research in the field. So we can start with the speeches. Now the agenda is full of interesting speeches. I would like to give the floor to Alessandra Liviero from Veneto Agricoltura, which is the leading partner of this project. And Alessandra will speak in detail about the goals, the results achieved, and the future development of the ITACA project. Alessandra, you have the floor.
Okay, thank you so much, Celia, for organizing this midterm conference for the ITACA project. My name is Alessandra Olivero. I've been working for the Venetian Agriculture Organization for the Veneto region, and we are partners of the ITACA project. I've been taking care of the coordination of the whole project. I want to share with you now the slides of the presentation. I hope you can see them. Okay, I guess you should be able to see them now. So the ITACA project is a project concerning about the blue innovation. Let's say this is an innovative method to manage the blue fish in the Adriatic Sea. Especially, we work with the anchovies and sardines, and we try to manage the economic aspect and the environmental aspect of these two fish species, especially the companies working with these two kinds of target fish. The duration of the project is quite long, and in this project, we have a whole series of meetings and contacts with the companies which work in this sector. During the pandemic, obviously, it has been impossible to properly meet and manage things. So we have had to extend the whole duration until the 30th of June 2022. In the bottom part of the slide, you can see that you have all the participants in this project between Italy and Croatia. So where did we start from? What did we think about with the ITACA project? First of all, we want to see what the trends are in the catches of the anchovies and sardines in the Adriatic Sea. We can see that we have had a decreasing trend, and as you can see in the graphs, we have had quite a moody, I would say, trend. Then, also taking into account many economic constraints. They can be internal constraints. Obviously, this is all referring to the bluefish in the Adriatic Sea. We have this uncertainty, which is intrinsic in the market demand and in the price, which obviously will have to be faced as a problem by the companies working in this sector. It seems like there's not so much competitiveness by the companies in the industry. And obviously, there's not so much power in the whole fishing chain. We have also external constraints. Think about, for instance, the regulatory framework, which sets many limitations, many constraints to the catches, to the production of fish products, and the companies, the businesses, from this point of view, are very limited and very constrained. Obviously, there is an environmental pressure. So we have seen one thing. We need to strengthen the competitive role and the capacity of operating for SMEs working in the small pelagic area. And obviously, we need to pay attention to the environmental aspects. And we need to protect these two fish stocks, especially. As far as the operators are concerned, we have worked very closely with them. We started speaking with them and working with them since the very beginning of the project by thinking about an adequate econometric model. And we tried to establish a proper ICT system. And this led to the ITACA app development. These companies worked with us. They gave us precious information to build this econometric model. We thought about the social, economic aspect, and thanks to our partnership, we also gathered other kinds of information, such as biological information, market information, and much more. The operators will be involved in the testing phase of this ICT system, this app, which I will shortly talk to you about what it is. And also we have organized a clustering phase in which we try to analyze this governance for this ICT system, which should be a benefit for much more time to come. Obviously, this is a tool for the small and medium-sized enterprises working with the small pelagic industry. So the main goal of the ITACA project is to develop, to create an application thanks to this system, to this model, which our colleagues will speak about later on. And the objective is to give to the small and medium-sized enterprises of the pelagic fishing industry a tool. And this tool should enable all of you to forecast the price which you may have with a specific species, where it is an anchovy or a sardine, in the very exact day they want to go out and fish. Thanks to this, the companies can be able to monitor the costs, the prices, because without saying, if the price is too low, the company or the producer organization may decide for the exact day not to go out at sea, obviously by taking into account the fact that this way the species can be protected. But at the same time, we will be sure, thanks to this app, to have an economic return. So we will optimize the catches from the point of view of the company, but also from the environmental point of view. What about the main features of this app? It's going to be there for operators to use it. We have been testing some of its features over the last couple of days, but shortly, later on, we will show you a few slides about how this app works. This tool will enable operators to manage this model, which has been created thanks to the ITACA model. This app will be focusing on a daily usage for operators. And so thanks to a simple tablet or a smartphone, this app will be very easy to use. Obviously, it should be used daily because we need to enter some data on a daily or weekly basis, and we will test it in the first week of October. The project is now in a quite advanced phase, at a quite advanced stage, and we are trying to close everything by working with these companies, with so many operators. Next week, we will organize a few training meetings for the producer organizations and for the cluster, which has been already identified project-wise. And later on, we will start the testing phase. In that moment, the app would be extended to the really operational world. Now, in order to close up, as I said, the small and medium-sized enterprises of the small pelagic fisheries in Italy and Croatia are the target of ITACA. As far as the approach by ITACA is concerned, we try to combine environmental and socio-economic sustainabilities. So we try to propose greater protections of these hectic resources. And at the same time, we try to better manage from an economic point of view the sector. And thanks to this tool, which we will introduce and get to know better later on, we will try to think about all the needs, for instance, of competitiveness and economic vitality of the companies working in this fishing sector, that is the small pelagic fishery in the Adriatic Sea. And on the other hand, we will think about the environmental sustainability, as well as protecting these two very important fish stocks in the Adriatic Sea. And with this, I have finished my very short presentation of what we are trying to achieve and what we are doing with this project. Thanks to all of you for taking part into this event. And now I leave the floor to Silvia or to the next speaker. Thank you so much, Alessandra. Thank you for introducing the ITACA project. Now, I leave the floor to Vanya Chikasket of the Oceanographic and Fishery Institute in Split, and she will present us the main characteristic of anchovies and sardines, and she will also give us a few hints on the state of these resources. I also remember for all other speakers not to speak too fast to facilitate the work of the interpreters. Thank you so much. Go on, Vanya.
Hello, everyone. My name is Vanya Chikasket, and from the Oceanography Institute in Split. I am a scientist, and I deal with the fish. Just a second, let me turn on my presentation. I hope you can see it. So I would like to say something about the small pelagics in the Adriatic Sea from the biological point of view. Small pelagic fish is economically important and a very important component of marine ecosystem, and one of the crucial forms from an ecological point of view, as it enables the transfer from a lower to a higher trophic level. In the Adriatic, it comprises of Sardine Crisis, Ingrollis and Rassicolus, Spratus, Scombrus, Scomber Japonicus, and Belone. The sardine and the anchovy are the most frequent fish in the Adriatic Sea, and not only, and they have a very important economic and ecological importance. Both of them are short-lived and fast-growing fish, and they are characterized that they migrate during their lives for 2 times. So they swim closer to the coast for feeding, and towards open waters for spawning, where they release their spawning products multiple times during one season. Both sardines and anchovies generally prefer to feed on animal food, although in sardines, a plant component was also part of the diet. Both populations, so sardines and anchovies, are connected to climate changes, which occur in hydrographic conditions, so decrease in salinity, increase in sea surface temperature. They may affect the quantity of the population. For both species, the age of first maturity occurs so when they first release their products. It occurs during the end of the first year of life. It depends on the length of the body and on the ecological conditions, especially quantity of food and temperature. When it comes to the sardine, Sardina pilcardus, it belongs to the Clypedae family, and it is distributed, where, as you can see in this photo, it is located along the Atlantic continental shelves of Europe and Africa, as well as in the Mediterranean, including its adjacent seas. The sardine is a multiple spawner, and it has a continuous gametogenesis, external fertilization, and after fertilization, there is no parental care. Here you can see the female and the male gonad, so where sexual cells are created. The fecundity is generally very high, but depends on the duration of the spawning season, on the previously stored reserves, and food availability in order to ensure the continuous development of gametes. When it comes to the spawning season, it is protracted. Thus, in the Adriatic Sea, the sardines tend to spawn generally from October to April, so the entire winter period. Here you can see the research conducted for a series of years. And generally it is always from December to February. Here you can see the eggs and larvae. They are also pelagic with oil drop, which helps them to move and to be within the water. Age is determined from otoliths. The otoliths are what you can see here in the photo. It is a formation which is located in the inner ear of the fish, and it is counted, so the opaque and hyaline bands formed are counted. It's like the trees that you have, the rings that you count. And after reading the otoliths, you receive a key like this one, and we can determine which length of the fish pertains to each age. So as I said previously, the species is an omnivore. It prefers animal food, but its diet changes seasonally in terms of feeding, activity, and prey quantity. So here we can see the prey. Generally, it feeds on copepods. When it comes to commercial age distribution, here you can see the situation in the entire Adriatic, not only on the Croatian or Italian side, but the entire Adriatic Sea in the last 20 years or so. And here you can see the age distribution of the sardines. So dark blue are those that are younger than 1 year. You can see that in the last few years, we don't have anymore the older units in the Adriatic Sea. Here we have some average masses of the ages. So here we can see that the age of 4 years is in decrease. Besides commercial research, we have two types of research that are conducted at the Adriatic Sea. So in it's an entire Adriatic, so Italian and Croatian part with scientific vessel, and once a month they go all along the Adriatic Sea, and here are the results that we receive. So regarding the age distribution, age structure, and here we can see that there is a lack of the older specimens. When it comes to landings, so in the Adriatic, sardine is mainly targeted by the eastern side fishery, and it's per signers that use artificial light to attract and aggregate the fish near the surface. The evaluation of the status and of the age of the population it considers the different regions, so 17 and 18. And sometimes you can evaluate the quantity of the resources in the sea. These are the quantities of the sardines, which says, I would like to explain that these dotted lines are thresholds, and the lower one is the threshold that shouldn't be passed because it means that it won't be recovered, while the upper line says that it should be below that line. When it comes to the sardine, you can see that the fishing mortality is very high. It is 4.43, and I'm sorry, the audio isn't good. Sylvia, I can't hear you. Can I go on?
Vania, scusa, non riusciamo più a sentirti bene. Non so se l'audio è tornato.
Vania, I'm sorry, but we can't hear you well.
Andare un pelo più veloce perché il tempo
Maybe
sta scorrendo
if
veloce,
you
siamo
could
quasi alla
go a
fine,
little
10
faster
minuti.
because time's running out. So yeah, that would be really appreciated.
Si sente ora, Vania? Ok, prego.
Vania, you have the floor again.
So I just wanted to say that this is overly used population. The anchovy is also distributed, widely distributed in Europe, along the Atlantic coast of Europe and Western Africa and Mediterranean Sea. Its main characteristic is a short lifespan, seasonal migrations. The difference is that it spawns during the summer months. Also, many times here, you can see the spawning on our side of the coast. These are eggs and larvae. Also, it feeds on copepods, and the majority of studies confirmed anchovy that they are omnivores. The age is determined from otoliths, and the age distribution in commercial landings. I'm sorry, I can't hear anything. The survey results show that it is a more stable status than when it comes to the sardine. But on the Italian side, you can see that the reduction of the younger individuals. So this is mainly targeted by the western side fishery with pelagic trawlers. The evaluation when it comes to the anchovies, almost the same as in the sardines. So it's overfishing status and it is overexploited. So this would be it. Thank you. Thank you. And I'm sorry if I took a little bit more than I was supposed to.
Grazie mille, Vania. Ti ringrazio per questa
Thank you,
intervento
Vanya,
di
for your
introduzione sulla biologia e
very
lo stato di
interesting
queste risorse.
introductory
Ora
speech
direi
on
che
biology
possiamo
and the state
entrare di nuovo
of
più
these
nel vivo del
resources. Now,
modello ITACA
we
e
can
andiamo
dive
a
into
vedere
the
più in
ITACA
dettaglio
model
qual è il
and we
modello
can take a
bioeconomico
look
che
at
sta
the
alla base
bioeconomic
dello strumento
model that
previsionale che stiamo
underlies the
sviluppando.
provisional instrument
E
that
partiamo
we
con
are developing.
Roberto
So we can
Pastres
start
che
with
ci racconterà
Roberto
la parte
Pastres,
più
who will
biologica
tell us
del modello in
about
questione.
the
Prego
more
Roberto.
biology-oriented part of the model in question. Roberto, you have the floor.
And I will tell you briefly what we added to the econometric model, to the ITACA econometric model in terms of, I wouldn't call it bioeconomic, a biological model, but rather a model that can provide some information about the evolution of the length and weight of small pelagics based on, I would say, an innovative approach in which we are trying to extend to fishery data assimilation. So in the first part of my presentation, I will briefly recap what we did in the project and how we set up the model for predicting weight and length of anchovies and sardines. And then in the second part, I will give you an idea of the approach that we would suggest to improve the prediction of the model based on real-time or quasi-real-time data that could be uploaded by operators. So the model that we used, in fact, was taken from the literature. It was proposed and applied to the Aegean Sea. And it was, to some extent, fine-tuned to match the data that were collected in the Adriatic Sea. Of course, as was said in the previous talk, it is very difficult to understand the source of food for anchovy and sardines because they have a very varied diet. And it is even more difficult to try to predict what can happen in the future to food availability. So the model that we have proposed and implemented make, of course, a very rough assumption that the food availability can be estimated on the basis of the net primary production, assuming that some of the energy goes through the next trophic level to the level of zooplankton on which these two species mainly feed. The other very important input that was mentioned is the surface temperature. Of course, the temperature changes with the position, the location, and depth. As a first approximation, we are using sea surface temperature as a proxy of the temperature that is actually experienced by the fish. Why are we using these two types of inputs? Because they are the only inputs that are freely available for the whole domain by downloading the product of the Copernicus Marine Environment Monitoring Service, which also provides some short-term prediction of these variables. So the idea is that we take this data from the portal, we use them as an input of two bioenergetic models, which are proposed in the literature, and we just slightly fine-tune, and we can get some forecast of the weight and by correlation length of these two small pelagic fish species. Of course, before going further, we try to check whether our approach was sound and could produce reasonable results. And we took some publicly available reports, such as those ones, in which, based on otolites, the age of, as was said, the age of sardines and anchovies was correlated to their weight. What we did was to test the model in 3 locations, within the FAO areas. We downloaded the time series of forcing function, temperature, and I put it ZOO as a proxy for the zooplankton density. And we then fed the model using these forcings. The results are presented or summarized in this kind of graph, in which you can see that the model is able to simulate reasonably well, for example, the evolution of the length of sardines and of the length of anchovies. So the second part of my presentation concerns what we hope could be done next in order to improve the model prediction and to get model prediction, let's say, on a short time horizon, let's say 10 days to 1 month, using a data-driven approach. As was said previously, there are many factors that can affect fish growth, and of course, there are many factors that can affect feed survival. We do not take them into account because this model is not a fully developed bioeconomic model, but looked only at the change in, let's say, average weight of fish. So in order to improve the model prediction, we suggest to use a simple data assimilation algorithm. Data assimilation is used nowadays in many areas, and of course, operational oceanography, weather forecasts are the 2 closer one to the present case study. And the idea is that you have 2 sources of knowledge: the model output, in this case, the prediction of the weight provided by our model, and the data. Both predictions, in fact, are estimates of the, let's say, true value of a given variable. In this case, for example, the average weight of fish at a certain point, at a certain location within a fishing ground. So the idea is that we can try to combine these 2 sources of knowledge in such a way that our estimate is closer to what we hope will be the true value. So in the app, which is under development, we will include a simple algorithm which, based on the data provided by fishermen organizations concerning where they fished, if possible, in terms of spatial coordinates and depth, and the average weight of their catches, if possible, with some estimation of the standard deviation of this weight, we can then take this data, process this data, which should be uploaded on a regular frequency, and combine them with the prediction of the model. The idea is that, assuming that the data are uploaded today, we can then select on Copernicus the forecast of the 2 input of the model, in this case, proxy of zooplankton density based on chlorophyll A and the temperature, and sample, let's say, this time series nearby the place which was indicated as the place in which the fish was caught, and then run the model a certain number of times with this slightly different value of the forcings. So the result will be, since we can access some prediction made with by the model available on Copernicus of these variables, we will have, let's say, 100 or even more trajectories of change in weight for the time horizon that is available in Copernicus, which I think currently is about a week or 10 days for these variables. So once we have run the model, we will have our two estimates of weight. One with the hat will be our model, and the one without the hat will be the average weight provided by fishermen. And we can then correct our prediction using a coefficient, this is this K, which is related to the confidence that we have in the two sources of information. This K, just to give you an example, if we quantify the confidence with the variance or standard deviation of the model trajectories and the observation, if we would have the same confidence, this will give you a K equal 0.5, which means that the correction will be halfway between the model estimates and the observation. The larger the variance, the lower the confidence, and therefore if we have a very large variance here in the model, the correction will be very, very small because this term will be high. Okay, so that's of course some conclusion because the time is running out. The attempt, it is in our point of view innovative. And will it work? It's difficult to say because, as I said, this is part of the next stage in the project that was described by Alessandra. We hope that the results will be interesting. Anyway, I also believe that in perspective, this would be a very good example of citizen science because, as it was remarked, the state of pelagic fishery is critical for different reasons. And having the possibility of collecting, besides the scientific data that were described, lots of data concerning the distribution of weight observed by fishermen, even though the accuracy of this information cannot be compared, could be very useful in the long term for understanding the state of the fishery. And as was remarked, for example, the recruitment depend on temperature, but depend also on the energy that was saved by the fish, and therefore, for example, determining through this system condition index on a very large scale and with a very high frequency can provide extra information concerning also what can happen in the near future to this to the fishery stocks. Okay. I think I can stop here and give the word back to Silvia.
For this very thorough description of the biological aspects of the model. Now I would like to give the floor to the next speaker, who will speak about the economic aspects of this model. Once again, remember to speak slowly in order to enable the interpreters to translate properly, but at the same time,
I work in the same organization of Mr. Pastres, who has just spoken to you. I'm working together with him to this project. I've been working to the econometric model as well, although I take care of non-biological aspects. I rather focus on economic aspects. I don't have so much time, so I decided not to speak of technical and statistics aspects because they would be very, very, very boring. So I decided to put at stake all the attention. I would like to all of you to focus on 3-4 results which we have achieved, which, in my opinion, are pretty important, pretty relevant. And obviously, this can be interesting results for the application of the operators we are working, but also for the users. Now, I will share the slides with you. Not so many, just 4 or 5 of them. Just give me a second, please. Here they are. So, just give me 1 more second, please. I would like to get a confirmation if you can see them. Okay, it would be better if we can start the presentation mode. Okay, it should be working now. Okay, perfect. So, I carried out a very similar analysis concerning, I did something very similar in between 2008 and 2011, a very similar analysis, a very similar work. And one of the features which we saw back then have been confirmed in this more recent study. So first of all, when it comes to the timing of the economic model, at the beginning, we were thinking about a daily model, but there are a few reasons which you can see there expressed in the first part of this slide. We thought of using a different timing, a monthly one, and maybe even weekly. Why did we decide to do so? First of all, it seems like not all partners of these projects are able to support and provide data with a daily application. They rather are able to do so just on a monthly basis. And when it comes to the economic point of view, we have seen a few things. We have seen a few things which can be expressed and explained economically. We have the elasticity of the market price compared to the supply which is provided. On a daily basis, we have a very small gap, very small difference. Obviously, it doesn't mean that this is not useful. As you can see in the next slide, we will see a few more data, a few more figures to understand. We have seen a high elasticity on a monthly basis. Obviously, we need to take into account also what the purchasers, the buyers have as an attitude. Unfortunately, we can never, ever have information about the purchasers' attitude. These are budget plans from these participants. I guess that we can only work effectively on a monthly basis. So the purchases are carried out according to the budget. So on a daily basis, as I said, we don't have so many differences in between the quantities which are offered from one day to the next one. Another motivation which really gave us motivation to abandon the daily analysis is that for the very same motivation, the purchases on longer time spans gave us the possibility to follow price quantity sequences which are not competitive at all, which is what we could expect a priori. As a sequence, it means that one day we have an X supply, the next day we have the open market, the quantity which is supplied, for instance, is higher, but the price is not decreasing as a competitive market regime would be expected. These are attitudes that on a daily basis are not explainable very well. Then, to confirm what I am saying, we have traded quantities in the presence of exact prices, which are very different. So here you have it. Here you can see a few examples in numbers and figures of what I've just said. I want to say that this slide and the next two slides have a few numeric examples, and in order to facilitate the comparison between different issues, this analysis have been carried out for my choice by using the same fish species, the European anchovy, and on the same trading point to think in parallel mindsets. The most important data come from December 2020. We can see that we don't have so much elasticity in between the days of December 2020. This is the fifth decimal after the comma. So if we focus on that, if we focus on those quantities, 10,000 kilograms have a difference of 1 cent. So this cannot be a good elasticity data. On a monthly basis, we have 0.43, so plus or minus 10% of product, of quantity, will have a price reducing by 4.3%. Then, as you can see, a number which can show you some of the last recent data. We have non-competitive quantities. So quantity increasing and competitive increasing, we have a price decreasing. This is almost 1/3 of the total quantities. It's not so little. And in this graph, you can see one more example about the numbers. We can see what I meant when I said that on a daily basis, we can see with prices which are exactly the same. Obviously, the price is the same. So just to give you an example, I chose €1 per kilogram, which is symbolic, with an oscillation range of 5 cents maximum. So 0.95 euros to 1.505 euros. With this minimum range of price, we can see how many quantities have been traded. At that price, we have traded 33,000 kilograms or 22 kilograms. Okay, now I'm at 600 kilograms. Obviously, 600 kilograms is what we had back in that day. But with these values, with €1, we have sold 33,000 kilograms or 25,000 kilograms or 15,000 kilograms. So if we follow the daily behavior of the demand, we cannot understand much out of it. So the fisheries, the fishermen wouldn't be able to carry out very effective strategies. And on a daily basis, fisheries have to face unpredictable situations. Another thing which we have seen is the gravitation area of the econometric model when it comes to the economic aspect. So we cannot think of building isolated models. So we can have estimates for each harbor, each port. So we cannot exploit data coming from that sole harbor. We need to have an Adriatic general model. Here you can see a table which makes you understand what I'm trying to say. We have built this model up to December 2020, but we also have the data from January 2021 and February 2021, which we have used to create these outsample simulations. The objective here is to see how the model is precise. So we have this actual price of January 2021, 1.16 euros. With an Adriatic model, we have just 1.15, just 1 cent of distance. In a single market model, we have 1.56 euros. If we only use the data of that harbor without taking into account what is going on in other harbors of the same area. This is the exact same thing I saw 10, 11 years ago. So why is that? How can we have different harbors being able to interact between them? Okay, by going on. This is the last feature. quantity-wise, which I wanted to show you. We have found out that the structure, not only the coefficients change over time, the econometric model is based on equations. It's an Alimax, technically. And here we have the regressors, which are, so to speak, playing the role of the lion. They are the relevant actor. Obviously, with the entry of new data, we have updated coefficients, but also we can see that we have an updated structure of the model, which has to be updated at least 4 times a year. So we have selected 4 different economic models over the same year. And we can group them this way. It looks like we have a January-February model, another one for March-April, another model for May, June and July, and finally the last one, which is September to December. In this case, we left August out. In August, many things cannot be fished, so we left August aside. The conclusion is that we need to update this model more than once a year. If the price of January 2021 Yes. We'll ask you to conclude, please. Okay, this is the last one. Okay. If the price is 1.16 in January 2021, with the model we had in October 2020 would have been 1.29. With something from November, it would be 1.48. And the price which we have at 1 cent distance is in December 2020. So this updating of the models cannot be done manually with the participation of just one operator. We have resolved this problem by implementing app routines, which are updated automatically by choosing the exact model for each part of the year. Quirina. And now we have seen this, so to speak, presentation of this bioeconometric model, which has been developing for the ITACA project. And now I would like to leave the floor to a speaker speaking about something more practical. We have Federico Bagato. He is part of the team developing the web app, and he will show us a preview of these two.
Manager of the team I work for. Today's presentation will focus on the main the web app we have been developing with the algorithms that have just been illustrated. And I will tell you about the calculations that will be made based on the data uploaded by users. The web app will be compatible with all mobile devices, namely tablets as well as computers. So every operator will have access to the app. The operator or the platform administrator will have access credentials that will have to be entered in the authentication screen, which is the one you're seeing now. And should the operator lose that password can be retrieved using the normal usual operations. Now, once you have accessed the web app, the app will perform 2 different functions, one for the operator and one for the platform manager. The operator will be able to access the economic and bioecological modules that have been developed by the professors, and it will serve as an intermediary in order to gather that data and feed the algorithm. Within the economic module, the web app will enable the carrying out of simulations by using data on the market and fishery in general, and it will yield results based on the algorithm. Now, using this interface, the operator able to upload, to enter their weekly revenues and information on the catch. Then the projection, the required projection will be displayed, and then the operator will be able to display the results and as well as the projection based on the data obtained. Now, as far as the bioecological model is concerned, there will be a specific session whereby the operator will be able to access and update the information on the size of anchovies and sardines based on fishing areas to A and so on and so forth. It will also be possible to specify the data and the average size of anchovies and sardines by confirming the data entered. The algorithm will run, thereby yielding results on future projections of sizes. This app can be used in many ways, and again, it works as an intermediary for operators to be able to use very complex algorithms. Now, I would also like to mention the admin profile, and project administrators will have full control of accesses and the organizations that can access the platform. Indeed, a platform administrator will have a further option, namely the users option, which you can see here. And on the user screen, it will be possible to add credentials, manage existing credentials, and changes can be made according to the reference organization. You can enter logos, you can change the color of the interface, and you can tweak all those little things that are needed to modify algorithms, the organization that is using the app. Here you can see the Interreg logo, and in this case, you can see all the different configurations that are available. Now, this has been a very brief overview, and this app is very user-friendly. So the screens are all very simple, very basic in terms of complexity. But our goal was to create a user-friendly interface so that the operator could use the algorithms that underlie the project. And this is it as far as the platform is concerned. And now, again, if you have any questions, feel free to ask me. So my presentation is over. So I will give you the floor.
Questa prima mattinata abbiamo appunto visto come i dati di tipo biologico, economico e
we have taken a look at ecologic, biological, and economic data and how this data can be used as part of models that can in turn be used to make predictions in order to help the marketing of fishery products. Now, we can now take a coffee break, a 5-minute coffee break, and I will see you.
Ben ritrovati a tutti, la pausa è stata breve ma spero sufficiente per
Okay,
un caffè.
thank you for coming back.
Ora ci
I hope you have
spostiamo un
been
po'
able
dal
to take a
progetto
coffee,
ITACA
and
e
now we
andiamo un
will
po' a
move
vedere che cosa
and
fanno i
leave the
nostri
ITACA
colleghi
project
anche in
just to see
altre
what
aree
our colleagues are doing in
in
other
altri fishery,
areas,
non solo
in other
dell'Adriatico,
basins, not only in the
vediamo
Adriatic Sea.
sempre come i dati
And
vengono
we will
utilizzati
see
per la
how
gestione delle
data,
risorse
once again,
idriche, per
is
i
used
modelli anche
for the
e
fishing
bioeconomici.
resources, for the
Cominciamo
bioeconomic
con
model.
il collega
We will
François
start with
Bastardi
our
di DTU Acqua
colleague François Bastardi
Danimarca che ci
from
presenterà il
Denmark,
modello
and he
Displace.
will introduce us to
Displace
the
ha già avuto un primo
Displace
sviluppo
model.
in
Displace
Adriatico,
had the
in
first
particolare sulle
development in
specie
the Adriatic Sea,
demersali,
especially
ma
with the
all'interno del
demersal
progetto
species.
Interreg Argos
But in the
avrà
Interreg Argos
un'ulteriore
project,
applicazione che
we will
includerà
see a
anche i
further
piccoli
application
pelagici.
about the small
Prego, François.
pelagic resource.
Can you see the screen?
Sì, ma ci servirebbe l'altro schermo perché
Yeah,
vediamo
but
le
we would
doppie
need
slide.
the harder screen because we can see double slides, please.
That one, you mean? Yeah, okay. Thank you for the hint. So yes, sorry. Thank you for the invitation. I will present you a modeling tool, actually, that is based on using those fisheries data. And then it's something that we have developed together with CNR in Ancona 3-4 years ago. And we are now planning to reuse this platform, that is a spatial fishery modeling platform, to include, besides the demersal fisheries already there, include the dynamic of the pelagics in the Adriatic Sea. Then it is starting from the fact that we know that the current situation is not that good for those stocks, and especially the demersal fish stocks, while we are having some ongoing regulation in place that are also spatial, but are found strongly insufficient to fix the situation and make those stocks recover. So this is why in this GSA 17 we would like to test an array of scenarios that could help make the exploitation sustainable. And this is why we developed an application of this displace modeling to the northern Adriatic Sea. Displace has been used in other parts of the European waters, but that one has been developed specifically focusing on the dynamic of the Italian fleet, together with the Croatian fleets. And the particularity of that kind of model is that it's tracking the movement of every fishing vessels. And is doing that because it's important to reflect what a single individual vessel is doing, where, what, and how, which kind of gear this vessel is using, that will have an impact, obviously, on the underlying exploitation of the resource by affecting the selectivity of the harvesting on that resource. So this is why it is an agent-based simulation model that is considering, as I say, the individual impact on the biology, but in turn, it will consider the impact of those fishing resource fluctuations on the individual economy of all those fishing vessels. So this has been, well, the strength of this model is that it's fully spatial. That means that we can investigate some spatial effects that are arising from those migration we were talking about, and those differential spatial distribution that the stocks that are being harvested could have, and see the effect of how likely the fishing effort will displace and will be redistributed in other parts of the Adriatic Sea when you start implementing area-based management. So this, as I said, this work has been already published some time ago with my colleagues from CNR, and we are trying to document what we are doing in a most transparent way. But this is really to gather all together those fisheries data and make use of it to project forward what could be in the medium term, 5 years ahead, the situation of those stocks. Are they able to recover, and how it affects the positively or negatively the economy of those fishermen. Yes, so it's using a bunch of data, so from individual vessel data. We are having from the logbooks, for example, or tracking their movement via the satellite data, those vessel monitoring system. We are having some ideas about their fuel consumption, their landings, their catch rate, and then the market price of those bunch of species. Here is only demersal species, but as I said, the project is to include the Anchovy and the Sardine as well. And we are using the spatial distribution of those stocks through the scientific survey ongoing in the area. That's the Medits and the Solomon for the sole, for example. And as I said, we are building that model to project forward and see what would be the viability in the future for those different stocks. And we are reflecting different fishing activities, different types. So here it was the demersal otter bottom trawl. There were the TBB, the rapido trawl that are being used in that particular areas, and the gill netters that are more small-scale coastal fisheries. And then we also included the activities from the Croatian fleets that so we have both sides of the Adriatic in that model. And yes, what is important is that this is, we see, for example, just focusing on the soil here, that depending on the size of the soil, depending on its growth, then along the edging of the soil, then the spatial distribution is moving and is changing. That means that we have the smallest individual close to the shore, while the adults are distributing in other areas depending on their habitat preferences or the habitat suitability to host that kind of fish stocks. On the other hand, for example, the spotted mantis shrimp is really well localized in well-known spots, and does not move really along the growth of the individuals. So there are particular life trait features like this, depending on the stocks, that will impact the efficiency of the exploitation of the stocks. And then this is a platform that's specifically dedicated to test management options for management that could be spatial management or non-spatial scenarios. So obviously everything is to test what would be the effect of changing the gear selectivity, either changing, for example, the mesh sizes of the nets being used, or the minimum landing size, conservation size, or on the other way, changing the spatial selectivity, where to fish to avoid the juvenile, for example, where fish to avoid having those unwanted catches. And then here, the practitioners can come with some suggestions for fishing closures that could be spatial closure, but also temporal closure, in an attempt to mitigate the adverse effects that those exploitation could have at certain time of the year or on certain ecosystem components of the Adriatic Sea. So we have this the Pomo closure, for example, and it's an interesting case where it's a shared closure between the Italian and the Croatian side. On each of them, we are having their own rules. We have 3 zones, A, B, C, and depending on where you are going to visit, you could be allowed to fish for 2 days a month, while on the others, you will be allowed to fish with certain type of gears and so on. So everything could be actually handled in that kind of model, so that to make sure that those managements make sense and have effects at the end of the day. So that kind of outcome we can see. So contrasting everything against a baseline where we know where the fishing effort is distributed in the Adriatic Sea. Then we look at the differences when starting implementing some possible scenarios, for example, closing or ban the trawling for this coastal strip for 4 nautical miles from the coastline, or 6 nautical miles, or as I was presenting, closing for certain part of the year and season, the Pomo pit that is having is well known for being a hotspot for biodiversity. And then you look at the change in the spatial selectivity you are inducing with those scenarios. And then because you change where the effort distributed in space and time, you are obviously changing the spatial distribution and the spatial composition of your catches across an area of species. And you see that you could actually study the effects for all the species pooled, but also looking at specific species your fisheries is having an interest with, and to inform the managers with some kind of and the stakeholders and the practitioners, some kind of relative change compared to the baseline, where the business as usual you are applying the same rules with and projecting forward the stock status, and you compare this business as usual with potential alternative paths, and see what would be the effect in terms of percentage on your landings, or your likelihood of discards, or your net profit value, or your energy efficiency, and even the income inequality you could induce actually by implementing that kind of area-based management, where some of those fisheries could be more affected than others, and some could gain more than others for some particular reasons. So we look at the trawlers and netters and the rapido trawls and see the gain loss of fishing opportunities from harvested stocks in better shape. And you can see a positive and negative effect depending on the scenarios, and exactly what we want to achieve is to document the possibilities for way forward. And I was mentioning the potential economic redistributional effects you could create and maybe impair the fairness of what kind of fishing communities could be hit by your management or the way around if everybody could actually gain from those management. And then you see that looking at specifically at PCAR per harbor communities, then you are also able to document what would be the likelihood of having a gain in revenue from your change. Is that a positive change for most of the fishermen or a negative one? And then again, we can focus on specific target species to see if there are viable solutions there to help fixing the situation. And this is my almost last slide, but obviously when you start changing where the fishing effort will distribute in space and time, then you can induce effects on the surrounding areas, especially because fishing effort will continue, but simply will be displaced in other areas. And this is where we could as well include some consideration about this ecosystem approach to fishery management, where you look at which kind of habitat will actually host the more effort compared to previous situation, and what will be the most probable scenarios to impact other habitats that you haven't foreseen in your data-driven approach. So yes, this is my last slide, just to mention that in this Interreg between Croatia and Italy, we in this Argos project, we are including the pelagics now on top of the demersal species I just presented. And then we will refine also to capture what would be the effect on the small scale fishing, and using the best available data that are fine enough to be close to what happened in the sea for each of those fishermen. And then we will test a row of bioeconomic effects. As I mentioned already, those changes in selectivity of the gears being used as a non-spatial, but also spatially. Also try to test alternative for quotas for the small pelagics in this area. Still looking at the pomo pit effect, and then looking at how some seasonal feature in the soil could be preserved by implementing some contrary for it. Yes, and then I would like to thank my colleagues in CNR that are deeply involved in this development. Thank you.
Thank you so much, Francois, for your presentation. Has been very, very interesting, and certainly we will follow the developments of the Argos project as well. Now we will change the area and we will move on to the Portuguese coasts, where they are studying a bioeconomic model for the fishing of the sardine with a specific fishing method. Renato Nunes Rosa will speak of it. And I now
inizierò condividendo lo schermo. Stavo tentando di contattarvi su Skype perché stavo avendo dei problemi, ma non serve più. Mi sentite? Prima stavo provando a contattarvi su Skype, ma come avete visto, ma stavo avendo dei problemi tecnici, ma adesso non, come vedete, non serve più.
Lascio così?
And I will start by providing you a little bit of context. What you see here in these graphs is the total landings of fisheries in Portugal mainland. The light blue is the total fisheries, and in the dark blue is the sardine fishery. And as you can see, the idea here that I want to convey with this slide is to show you that the sardine fishery in Portugal is extremely relevant. It accounted for mostly almost 40%, or actually more than that, 40% of the total landings in terms of volume, and roughly about 20% of the total landings in terms of value. So it is a really important fishery in Portugal. And sardines, they are mostly harvested by the purseine fleet. And if you look at the landings profile of the purseine fleet in Portugal, we'll also see that in the beginning of the century, this entire fleet was basically depending on sardines, right? So sardine landings account for roughly 80% of the total landings of this fleet, and also about roughly 80% of the landing value of the purseine fleet in Portugal as well. So very relevant fishery in Portugal, an entire fleet depending on this species. And what happened in Portugal during the last 20 years is that we had several crises, and one of those crises was exactly the sardine crisis. And what you see here is the evolution of the biomass and of the harvesting of sardine in Portugal. So the dark blue is the total biomass. You read it on the left axis, and the harvesting is the light blue, and you read it on the right axis. So you see that we passed from the beginning of the 80s from an extremely abundance of like 1,000 tons of biomass to something like 200,000 tons of biomass today. And harvesting that was above 150,000 tons per year to something like 20 today. So this obviously had huge implications for the entire fishery economy in Portugal, and obviously for the purseine fleet. So what happened in Portugal was that in 2012, sardine fishery management plan was introduced. I'm sorry that the left graph is in Portuguese, but I couldn't find the English version. But what you have here is the harvest control rule that was implemented in Portugal in 2012 to 2015. This harvest control rule is no longer in place, but since then, their quotas have been set every year, and the reduction that was set by these quotas was extreme, and it's still relevant. It's still taking place today. And so this is the harvest control rule. It's a regular kind of harvest control rule, defining the total allowable catch per year, has a function of the stock abundance. And it was a harvest control rule based on biological reference points, as almost all harvest control rules, if not all harvest control rules in the globe are. So there was absolutely no consideration of economics, as it usually happens in fishery management. And how did this management, how did this policy go? So what you see on the left side is the harvesting since 2000 of the Portuguese purseine fleet. And you see that after 2012, there was a huge reduction in captures. So it passed from 80 to something below 20. And what was the effect on the biomass? Well, as it often happens, unfortunately, the effect on biomass was not immediate. So there was a very long recovery period. And only now we are seeing some recovery of the stock, some weak signs, well, some signs of recovery, at least in the last 2 years or so. So this is basically what fishery policies look at, but this has obviously economic implications. And there were some relevant economic implications resulting from this policy. And here is one. So if you look at the landing profiles on the left, you see that after policy implementation, there was a huge reduction. It started actually a little bit earlier. And what you can see on the graph on your right is that until 2012, the price was extremely low. It seems more or less in line with the prices in Italy. It was around 80 cents per kilo. But when you saw that huge reduction resulting from a policy implementation, the effect was a huge increase in prices. So this is yearly prices, but you can also see, of course, these changes in monthly prices as well. And obviously with the seasonality that it seems to exist also in Italy. But I mean, it was a huge increase in prices. It was more than double. So you passed from 80 cents to something like €2 a kilo. So from a pure research perspective, this was interesting because it helped us to essentially characterize better the Portuguese demand for sardines. What you have here on the graph on your right is giving you basically this set of points are the set of points before policy, and after policy you start having these ones. So you see, you can start, though there is a shock in supply, right? So you can identify better the demand. And this was very, very relevant for us as researchers, but this is obviously very relevant for the fishermen as well. And what I'm showing you now on the right is the revenues that were generated in the Percine fleet by fishing sardines on. And what you see is that even though there was a huge reduction in the landings after 2012, there was still a reduction in revenues. These are all nominal values. I have not calculated real values, but you get the feeling of what I'm saying despite of that. But what happened in revenues is that the revenues fell, but they clearly didn't fall as much as the quantity, and obviously because there was a price effect that compensated the decrease in the harvested quantity. Now, this could be good news for fishermen if you think that you are fishing less, much less, and gaining more or less the same money for it, but you cannot actually state that because you don't know what are the effects on the costs of fishing a lower quantity, given that the abundance is lower. So these kind of questions are very relevant to take into account, but they are usually not taken into account when you are defining a fishery policy. And so you should actually try to do that, right? To inform fishery, to somehow bring economics into fishery policies because of the relevant effects that we just saw. And what happened is that economists usually work with the Schaffer models in population dynamics in bioeconomic modeling. So, one of the ways to introduce economics into fishery management is to bring bioeconomic modeling like the one that Francois just presented. The problem is that when economists were developing bioeconomic models, they were basically working with a population dynamics model using the Schaffer model, which is very simple, and marine biologists were using much more complex models like the Beverson-Holt model. So there was this clash, let's say, between economists and marine biologists. Marine biologists tend to look at the Schaffer model as something that is useful from a pedagogical term, but if you have better data, you can do better, and you should use a Beverson-Holt model. And therefore, economists were not able to inform fishery policies because they were looked with some distrust on the way they approach the modeling of fish populations. Now, these things changed recently, and essentially because of computational power, now economists can actually use bioeconomic models using the same kind of models, population dynamics, that marine biologists do. And that's what we did in Portugal. We have used exactly the same population dynamics used by IPMA, which is the institution in Portugal that does the assessment and the evaluation of fishery policies. And we have constructed a bioeconomic model using that same population dynamics. There is a problem though when you increase your complexity. I'm not going through the equations, but it's just to give you a sense that the complexity of a bioeconomic model really increases a lot when you use more complex population dynamics. And this has a consequence as well for the kind of information that you can use from a bioeconomic model to support the design of fishery policies. And one particular problem is that if you use a very complex population dynamic, more complex population dynamics, such as the Beverton-Holt model, you can no longer use your bioeconomic model to derive a harvest control rule, something that you could do before when you were using more simple models. And the reason is very straightforward. It's because the optimal level of harvest does not depend on the biomass only, it depends on the composition, on the age composition of the biomass. So you cannot determine how much you should harvest based on a single index as the biomass. You need more than that. Well, that's a problem, but what we found in this paper that I've done with some other colleagues, Tiago Costa and Rui Mota, was to use this bioeconomic model for the fishery, for the sardine fishery in Portugal. And what we saw was that even though this is true, that you cannot define a harvest only as a function of biomass, if the model satisfies certain quantities, you can approximate the optimal solution of the model in that state space. So basically, you can define a harvest control rule using a bioeconomic model in the same state space that is used on current fishery policies. So this means that your harvest control rule that comes from the bioeconomic model is taking into account precisely the same population dynamics information used today to define fishery policies, but you are accounting for economics as well. And what we did in this paper was to study that under two population scenarios. One where you have the one on your left, you have a compensatory population, and on the one in your right, you have a critical depreciation population. We assume critical depreciation. So basically, this means that on your right, the population dynamic is modeled in such a way that the number of recruits per capita decreases with abundance, and therefore you can have collapses in the stock, and it gets much harder to recover the stock once you are at very low levels of abundance. And then what we did, I'm not going through details, we can discuss that further if you are interested in it. And what basically we have handled is a bioeconomic model that is providing you a fishery policy that endogenously capture economics, and then also allows you to simulate these policies under stochastics. I'm almost finishing, Silvia. Is it that? Yeah, how much minutes do I have? 2, 3?
Puoi andare, Renato, hai ancora 4 minuti.
Okay.
You still have 4 minutes.
And so you have this fishery policy that is capturing these economics and biological aspects, and you can simulate these policies and they directly compare the effects on the biology side and on the economic side, and therefore you're providing information for policymakers that then can choose how to trade off more money with less abundance, or the other way around, right? But obviously, I've been talking only about sardines, but the Persian fleet fishery is not only about sardines. It had other species as well, and these graphs are showing you the effects of that same policy on the landings now of chub mackerel and horse mackerel as well. And what we observed in Portugal is what you would expect, is that when you are decreasing the amount of sardines that you can harvest, you will increase your pressure on other species, something that Francois was also talking about. And in Portugal, what happened was that the amount of chub mackerel that was harvested increased a lot during the policy period, and you cannot see that much here because of the scale, but the horse mackerel captured by the Persian fleeter also increased a lot, it more than doubled. And this had an effect in prices as well. So we have already discussed this, the price of sardines increased, but the price of horse mackerel decreased. And this is very important to take into account when you're looking at displacement of fishing effort, because this means that the horse mackerel can be a substitute, but it becomes a less interesting substitute because you are decreasing the price of that species. The same did not happen with chub mackerel, though. So yeah, so you have basically what I'm trying to say is that you obviously, something that is a consensus is that you must look for an ecosystem-based fisheries management approach. And this is what we are doing now in the context of this project here, it's called Sardine 2020, where we are developing a new bioeconomic model. This time is not a sardine fishery bioeconomic model, it's a per-scene fleet bioeconomic model, where we are capturing where the fleet is harvesting 3 different species: the horse mackerel, which is modeled as an age class population, the sardines, and which is also modeled as an age class population, and the chub mackerel is modeled as a biomass population because we don't have enough data to do better than that. And so there are economic interactions occurring here, and there are technical interactions occurring here, and there is a trophic interaction between chub mackerel preying on the sardine larvae and eggs. With that, we are also considering market interactions. This means that we have demand functions for the free species, and this means that when I am increasing the quantity of fish of a certain species in the market, I will observe a reduction in the price, in the yearly price of that species, and therefore the effects that I was discussing before are taken into account in that model. If we are lucky enough, and this is being harder to do, we will also try to include some environmental variables affecting the recruitment of sardines, and therefore we will be also able to look at this in different climate scenarios. We already have this model running. It's a preliminary version. I think it will be concluded in about 15 days or so. I mean, we're just concluding the final simulations. And if there's interest in someone in this audience interested in knowing more about this, we can talk afterwards. And that's it. Thank you.
Grazie mille Renato, la presentazione è stata
Thank you very much, Renato. Your presentation has been very, very interesting. Now we can move on to the north of Spain. At the beginning of the 2000s in this area, there was a great decrease in fishery stocks, but the good management of this stock enables a recovery of this stock as well as of fishing activities. So Leira, you have the floor.
Yeah, thank you, Silvia. Thank you very much for the invitation to be here today. So let me share my screen. Can you see my screen?
Perfetto, sì.
Okay, very good. So, as Silvia said, I will give you a quick overview of how the management of the Bay of Biscay anchovy has been evolving in the last years. So, anchovy in the Bay of Biscay is assessed every year by ICES and is distributed in this red area you can see here. As you all know, this is a small pelagic fish with acrobatic behavior. It is short-lived, so it lives 3 and at very most 5 years. They are all mature at age 1. Spawning occurs in spring, and it has a high and variable natural mortality with very variable recruitment as well, depending on the environmental conditions. So this fishery until more or less the 2000s, more or less, you can see here in this plot the evolution of the fishery. So we have records starting in 1940. There was an increase in the catches, up to 80,000 tons here and around 600 vessels fishing. Then you can also see the blue ones are the proportion of the Spanish catches and the light orange ones, the French ones. And you can also see a gradual introduction of the French fishery into the fishery. The monitoring of this stock with surveys, with the daily egg production method and with acoustic surveys started at the end of the 80s with these two surveys, Biomass and Pelgas, and the first stock assessments were conducted in 1995, more or less, in ICES. So the first TAC for this fishery were established in 1986 when Spain entered into the European Economic Community. And as you can see here, this black line here, the TAC was set more or less constant between 30 and 33,000 tons, regardless the scientific advice. And further than that, you can see that this TAC wasn't really regulating the fishery because in some years the tag was exceeded, and in some others the catches were far below the TAC. So what happened with this? As you can see here, and this is the same figure with the evolution of the catches, in 2001, after a series of consecutive recruitment failures, the catches started to decrease very sharply. And in 2005, the fishery crashed. So fishermen went out fishing, but they weren't really able to fish. And the fishery had to be closed. So the fishery was kept closed until 2009 because recruitment was being very, very bad in those years, and the biomass was below the biomass reference points. So the status of the stock was really bad. So what happened during this year of closures? As you can see here, right before the closure of the fishery in 2003, it was the beginning of the autumn acoustic surveys. These surveys try to evaluate the biomass of juveniles. That is going to be the recruitment in the next year. So it's trying to follow what is happening in the stock in order to put an adequate management plan next year. So in 2003, it was the first of these surveys that have continued up to now. In 2005, as we have seen, it was the fishery crash and closure. And during this closure in 2007, the European Commission launched a non-paper. And there, in that document, they basically established the management objectives for these stocks, and they try to set the basis for a management plan for this stock. At the same time, in that year, it happened the foundation of the Southwestern Water Advisory Council that had a very active role in the development of a management plan. So 2008 was a very, very busy year. There were several STCF meetings trying to develop a management plan for this stock based on the European Commission non-paper. And these results were presented to the different stakeholders, to the European Commission and also to the Southwestern Waters Advisory Council. They provided feedback, so they requested more analysis, more simulations. Those were done, they were again presented. And after all these discussions, next year in 2009, the European Commission had the first proposal for a management plan for this stock. So during all these years, the fishery was still closed. But in 2010, the fishery was reopened, and it was reopened because these autumn acoustic surveys that started in 2003 pointed to a very high recruitment coming in. The biomass was at safer levels, so biomass was above BLIM, the biomass reference point. And based on this good recruitment perspective, the fishery was reopened with a preliminary TAC, preliminary TAC of 7,000 tons. Then in spring, the usual stock assessment was conducted, and in July of that year was the first time that the management plan was applied. So what is under this management plan that was first applied in 2010? So under that plan is this harvest control rule that you can see here that basically set the TAC based on the estimated biomass from the stock assessment. The elements of this harvest control rule are that the management calendar goes from July to June, so everything goes very quickly. So in spring, we have the 2 spring surveys. Then after the surveys, the results are directly used in the stock assessment that is conducted in June. And from that stock assessment, immediately the harvest control rule was applied and the TAC from July to June next year was established. Okay. So then you can see also that this rule is in terms of catches, not in terms of fishing mortality. It has a maximum TAC here of 33,000 tons, but then it also has this value here that it's set at 7,000 tons. That this was established with the fishing sector. This 7,000 tons was the value that they deemed that was the minimum economic viable catch for them. Okay, so below those 7,000 tons, going out fishing wasn't really economically valuable for them. So this was set in communication with them. And then the harvest rate in this period here between this minimum TAC and this maximum TAC has a harvest rate of 0.3. So they are basically fishing 30% of the estimated biomass. But this management plan established in 2010 is not static at all. It had a clause to be revised periodically. And it has been revised several times since then. The first revision was with the introduction of these autumn acoustic surveys. So these surveys, as you can see here, the black line is the survey estimate, and the red line is what is the recruitment estimated by the assessment. And you can see that they are really, they go very, very much in parallel. So this survey was very good for estimating recruitment. So based on that, ICES decided to include that survey into the stock assessment. And after that inclusion that was conducted in 2012 and 2013, the management plan was revised into meetings, and a new rule was adopted, and management calendar was changed again to January, December, because recruitment was already into the stock assessment. So it could be used to set a management plan for this period again. So as I told you, besides the change in the management calendar, the rule also changed a little bit. So you can see also that this gray line is the initial management plan, and this black dashed line is the new management plan established in 2013. Okay. You can see that the maximum TAC was a bit lower, but also it allowed a bit larger catches in this for these intermediate catches, biomasses, sorry. But still, in 2016, the Southwestern Water Advisory Council requested a change of rule, increasing the maximum TAC from 25,000 tons to 33,000 tons, And this was accepted also by the European Commission, and is what it has been really been applied since 2016. So one thing I would like to highlight here is the importance of the management calendar, as this is a short-lived species with very fluctuating dynamics. What has happened in the changes in the management plan is that the calendar has been really changing to use the information as soon as it was ready. So even in the beginning, there was no information on recruitment, and it was a constant TAC was applied. The first management plan really used, as soon as the spring surveys and the stock assessment was conducted, the TAC for the next year was established from July to June. But then when the acoustic surveys on juveniles were incorporated, then the assessment was moved right after those acoustic surveys. And then the TAC changed again to the January-December management calendar. So really these management plans are trying to use the most updated information and providing the management advice very, very fast. So this is just a very quick overview of the trajectory of the anchovy catches. As you can see here, after the reopening, the catches have been again raising, and they are more or less above between 20 and 30,000 tons in the last years. And here you can see the biomass, and the spawn stock biomass is well above the biological reference point. So the population is in a good status. So key elements of this recovery and the development of these management plans has been, as I told you, the management calendar. So we have been really adapting this to the monitoring system to provide advice as soon as the results of the surveys and the assessment were ready. Then also a very close monitoring using research surveys and also monitoring the fishery, the catches. Also the juvenile autumn acoustic surveys with the ability to forecast recruitment were very important in this case, because the population is very dependent on this recruitment, and recruitment fluctuates a lot depending on the environmental conditions. So the ability to have these surveys with a good predictive power were very good. And then also the process of this management plan has been very, very participative. So there was a lot of communication between the fishing sectors, scientists, and managers. So basically the conclusions are that this stock represents an example of successful management. We have already seen the key elements. And really, since the recovery of the stock and the first implementation of the management plan that has been also evolving a long time, this fishery has been exploiting sustainably the anchovy resource, and the anchovy stock right now is at a healthy status. So that's it from my side. Thank you very much.
Grazie Lere, grazie per il tuo contributo e per averci mostrato gli effetti.
Thank you so much for your contribution and for showing us how important it is to manage properly stock like the anchovies. And now I will leave the floor to two other Interreg projects. We will start with Simone Librelato from the National Oceanographic Institute and Experimental Geophysics, as well as coordinator of the EFC project. And he will show us a more systemic approach to the marine ecosystem and the results which have been achieved recently. Thank you.
Grazie
Good morning. Thank you for inviting me. As you said, I hope you can see my presentation. Okay. As Silvia said, I will be presenting the results of a project that has just been concluded. But as you know, it takes a long time for a project to be ended. But the title of the name of this project is Fair Sea, Fisheries in the Adriatic Region, a Shared Ecosystem Approach. Now, the starting conditions are the ones of the Adriatic Sea, and they have required the involvement of various institutions, both scientific and non-scientific. And we have involved institutions both from Italy and Croatia. And this has enabled us to achieve shared goals and to deepen all policy levels, from the local level to the international level. Now, the starting point, the background, is the one that has already been discussed, namely a critical situation with regard to the fisheries sector in the Adriatic Sea. This situation is to be solved taking into account environmental, economic, and social factors. The idea underlying the project focuses on the building of a platform that contains information that is accessible to everybody. And this platform has been used and will be used for various activities. So the idea is not only sharing knowledge, but also building a system that can be used for planning purposes, thereby fostering participation and achieving a consensus on management. The platform has also proved useful in order to enhance knowledge and skills in a complex environment such as the one of fishery. Now, I will give you an overview of the platform. The platform has been divided into modules. These modules contain various kinds of information, going from oceanography to socioeconomics. And these modules are interlinked. The platform can be accessed online. And now I will give you a brief overview of the platform, provided the video works. Basically, the platform contains information on on physical variables, for instance, when it comes to the Adriatic Sea. And the resolution is 7 by, is the one you see on the screen. And we also have data on salinity, for instance. This information has been used as part of the model, and the modules contain also data on production, particulate organic carbon, and the data is very similar to the data presented by Professor Paspers. And this kind of information is not always available on the Copernicus platform, for instance. And this data has been considered as useful in order to give a context, to give an environmental context to the whole thing. And now there's also data with regard to the distribution of resources. Now, the platform contains information on the distribution and quantity of many species. And there is also information, very complex, information that is very complex to find on harvests. And the information is divided by regions, by fishing techniques, by length of the boats. And on top of this information, there is also information on the so-called vessel monitoring systems and data on the various fleets. And this data is the result of a joint analysis carried out on the basis of both Italian and Croatian data, and thanks to the participation of the ministries for agriculture of both countries. This data is combined, as I was saying, This data is combined as part of various models. Thanks to the contribution of our scientific partners, we have been able to create a socio-economic model that is not specialized, but actually represents the dynamics of stocks and a number of management activities and based also on information of economic information. And you see, we have used the BEM, the so-called BEM tool, to create management scenarios. We have a status quo scenario, a status containing the initiatives of the multi-annual plan, and a scenario containing combined measures. The BEM tool.
Ti chiediamo se è possibile,
Simone, I'm
se
sorry,
riesci a
could
rallentare un
you
po' per
go a
i
little
traduttori.
slower? I'm sorry,
Grazie.
because some of the interpreters are having trouble following you. Yes, I'm sorry, I apologize. The idea was to use this instrument, to apply it to 3 management scenarios. And these scenarios can be compared, and the results of this comparison are available online on the platform. The scenarios have been created not only on the basis of the indications of the multi-annual management plan, namely the transition phase, the subsequent reduction of the fishing effort, but there are also simulations in effort reductions, those envisaged by 2026. Trawlers and Rapido, and a complete scenario has been created where the combination of measures has been created. And we have also taken into account the data on selectivity, and these scenarios are compared with using utility indicators, which the COISPA has applied, and all of this is available online. These results enable the highlighting of the preferences of the stakeholders involved in the project. And for instance, in scenario 2, you see interventions on selectivity as well as the reduction in efforts. Another type of model has been used as well. This one is of the spatial kind. It is a smart model. I'm sorry. This model is similar to the displays that Mr. Bassoli presented earlier. This model includes data on BMS and AIS. We have combined this data with logbook data. We have identified the fishing ground for target stocks. We focused on demersal species, and we have combined the data of Italy and Croatia. This has enabled the implementation of the smart model in order to assess scenarios that are very similar to those those we spoke about earlier. So the 6 nautical mile closure, reduction efforts up to 2026, and the inclusion of a 65-day fishing ban. The results show that there is an immediate negative effect on fishery activity when it comes to the entry into forcible measures. And the measure that is the most critical for most species is the 6 nautical mile closure one. But in some scenarios, there is a recovery after 3 years. This is due to the fact that the model represents the ability of the system and resources to grow again, to start growing again. So we were speaking about stock rebuilding, and this has positive effects. Also, while keeping the reduction effort with regards to some species. We have also used the data of the platform to develop another model, which is a bit more complex, because on top of having the spatial distribution of fishery activities, we also have a dynamic representation of many resources that interact with each other. We have applied the ecospace model by taking into account not only the available data in terms of distribution and abundance of resources, but also environmental variables, the environmental variables that have been studied during the project. And these variables serve to best represent medium long-term dynamics when it comes to resources. Now, I would like to remind you that the project represents the 2 decades worth of data, and this model has been used, it's been created using data from 2004 to 2018. And the model also represents all management and administrative areas, both with regard to Italy and Croatia. And the specialized representation of all fishery activities is included. This instrument has been used to carry out several scenario tests. We have not only tested the sensitivity and changes in harvests and so on. We have studied the introduction of a sanctuary in the northern Adriatic, or the Barry Canyon in the southern Adriatic Sea. We have represented the effects of the closure of the 6 nautical mile closure, but we have also run scenarios, future management scenarios. So with their effort reduction, the SC2, or a reduction in effort with all possible management areas that have been previously described. There is another scenario with climate, taking into account climate data up to 2050. Now, we have achieved many different results. We are working on them, but the scenarios show that management activities envisaged in the multi-annual management plan will have a very strong negative impact on resources and fishing activities, and this is in the short term, and resources will recover. As you can see, for instance, here in this graph, take a look at the gray line, the Murus barbatus, and our recovery will be possible by keeping fishing efforts intact. So there are very positive medium and long-term effects. But if there is one thing we have seen, is that there is a negative effect with regard to the climatic counterpart. So the management of the future will have to take into account important variations that are already taking place within the ecosystem, and this is in terms of environmental variables. We haven't summarized all scenarios of yet, but I just wanted to give you an idea of the main results. This is the end of my presentation. I would like to thank you for the invitation. I would also like to thank all the partners who have enabled us to achieve all these very interesting results. Thank you for the attention. Thank you, Simone. I would like to congratulate the partnership on this platform, which contains a huge amount of data and models. And this platform will most certainly be used as part of future projects. So thank you for your efforts. Thank you. Now we can move on to Sushi Drop, another Interreg project. We will speak about it with Luca De Marchi from the University of Bologna. Luca is the coordinator of the Sushi Drop project, and we will embark upon a very brief trip into the sea.
A very quick presentation before the video. So, I'm going to introduce to all of you the Sushi Drop project. Sushi Drop belongs to the Italian creation framework for this program. Between the target actions, we also wanted to develop a monitoring system to increase the knowledge about the submarine habitats. And this is why we created this Sushi Drop project. This is our response to these requests. Here you can see the main outputs of our project. We have the submarine drone and unmanned underwater vehicle. This has been developed ad hoc for the Adriatic Sea features, and the data obtained by the drone in a number of missions should be included in an open access database. Starting from this data, we will be able to develop strategies for biodiversity conservation. We started this project in January 2019, and it will close this year in 2021. As far as the partnership is concerned, we have 6 partners. We have both scientific institutions, especially the University of Bologna, for which I work, and the Oceanographic Institute of Split, as well as local authorities, for example, the Marche region in Italy and the Dalmatia Split community, as well as fishermen environmental associations such as the Costa dei Trabocchi and Sunze. As far as the main objectives, as I've said, we want to create this kind of drone. The submarine drone technology has been developing very strongly over the last couple of years because we have many different applications we could implement. This is true from the scientific point of view, as well as from the Sushi Drop project, as well as the oil and gas and other commercial industries. These WVs can obviously be a solution to our lesser knowledge of submarine habitats. Thanks to this technology, we can get to greater depths, which usually are impossible to reach for divers. And thanks to this effective planning, we can also get data in a quicker and more efficient way, as well as, it goes without saying, the economic results, which could be much, much greater. As far as the ad hoc challenges for the Adriatic Sea, what we were interested into was to monitor some rocky areas which are in the Adriatic Sea. Although, as we know, in this sea, we mainly have muddy and sandy areas. And yet we have a few hotspots, which are particularly important when it comes to the biodiversity point of view. So if we are able to monitor these benthic habitats, we can achieve the first and primary objective we set for our project. So we created this kind of drone, a drone which has a modular structure. Therefore, thanks to the modularity, according to the different missions, we can reorganize this UUV. We can reach up to 200, 300 meter depths. And we have different sensors, which are very, very top-notch technological level. We have a multi-beam radar for ultrasound monitoring. We have high-definition cameras, and we have highly advanced features for the heading and the control of the technologic piece itself. One of the other objectives is to give this drone the necessary intelligence to manage it in these waters. Now, I am very, very happy to show you a few pictures, a few images which were taken in a number of different missions which we developed in the Croatian and Italian waters recently. So I would start and show you the video if possible.
Grazie Luca, e direi che anche Sushi Drop avrà un importante futuro nel campo delle ricerca in mare. E ci avviamo quindi verso la fine della mattinata. Se ci sono domande potete utilizzare la chat, e altrimenti ci avviamo verso le conclusioni. Vi ricordo comunque che potete contattare noi del progetto ITACA o direttamente i relatori per eventuali curiosità e chiarimenti. Aspetto qualche minuto per vedere se arrivano delle domande, altrimenti concludiamo la giornata. Ok, direi di concludere, anche ormai l'ora ci fa più pensare al pranzo.
So, we're running a bit late, so we can draw to a close, but feel free to write to us should you have any observations to make or questions to ask.
Mi avvio quindi a concludere prima di passare ai ringraziamenti.
No, before moving on to the acknowledgements, today's event has shown us the importance of data in research in this field. We have spoken about biologic, economic, social data. We have also seen that the question of fishing stock, especially pelagic fishes, does not only concern the Adriatic Sea, but also other basins. So we can draw inspiration by other areas for a more virtuous management of our fishing stock. Now, when it comes to the ITACA project, the project will see its pilot action begin in a few weeks, and we will be testing the web app with the help of the institutions in the sector that will be involved in the project. Hopefully, the app does not remain confined within the ITACA project. Hopefully, it will be used also in the future in order to help the preservation of these species as well as other fish stock. Hopefully, it will be used by all institutions on the Adriatic Sea. So now I'd like to thank the entire ITACA partnership and all the colleagues of IRBIM for organizing this conference. I would also like to thank the Imagina company for the technical management of the event, the Get It company for the interpreting service, and as well as the technical staff. This is the end of the event. Thank you for your attention. Enjoy the rest of the day. Thank you for following the event.